Hello, CSEC students. Welcome to another live class. And we are looking at types of angles. So this is trig. Trig kind of where trig meets geometry kind of thing. All right, so we have to understand the basic concepts of the different types of angles in order to solve the problems that we're going to get in trigonometry at any level, right? So this is the basic trigonometry knowledge, types of angles. All right, so get ready, get your books and pencils ready, and we're gonna go. All right, so while I wait for my students to log on, so the last class we did on trig, we talked about the types of triangles, different types of triangles, and some of that will be discussed today because some of the triangles are named based on the kinds of angles that they have. All right, so bring that knowledge over into this class. So those who were at that class, whether on the live or you access it later after it was posted, all that knowledge that we talked about, the different types of triangles, we're going to be using that. So for example, the right angle triangle is named for the fact that it has a right angle. The obtuse angle triangle is named for the fact that it has an obtuse angle, and the acute angle triangle is named for the fact that it has 3 acute angles. So we're going to find out then, what do we mean by right angle? What do we mean by acute angle and obtuse and all of those nice things? So here we go. So we're going to start with the smallest one, the acute angle. All right, now, what's an angle, first of all? What's an angle? So an angle, you could say, is a space that is formed when 2 lines, or more specifically for math, when 2 rays meet each other at a vertex. So this is a vertex, the point where the 2 rays meet. Right here, that's the vertex. And actually, where you have a vertex, you automatically have 2 angles formed, believe it or not. So it's not just this space that's the angle. We automatically form another angle out here. So depending on what is our focus, we might say, or if we're focusing on this area, and if it was partitioned off in, let's say, a triangle, and this is our focus, we would say this is the interior angle, and then this one would be the exterior angle, the one on the outside of our focus, right? So likewise, we can have a situation like this, where you have the triangle here with the 3 angles, 3 interior angles. Here we have an exterior angle. Here we have another angle being formed, right? So once 2 rays or 2 lines meet, that is the angle. Angle is formed. The angle, so this space, right? The space that it takes up between the two rays, that is the angle. Now the acute angle is less than 90 degrees. So we measure angles using a protractor. That's a mathematical instrument. It's shaped a little something like that, kind of, sort of, maybe like that, a semicircle. So usually it's transparent, so you can see through it and see the lines under it. And we usually have a little cross there. And then you have the angles where you can measure from the left or from the right, from the inside or the outside. So you will have numbers along, and you can measure the angle, whether it turned that way or it turned that way, right? You can put the protractor at the vertex and get your measurement. So if you measure any angle using the protractor, or if you are given the measurement of any angle and it is less than 90 degrees, I mean, like even 89.999999999 degrees, it's still acute, right? So I'm sure you can think of many numbers, because we would include decimals, fractions. So 25 degrees is acute. 40.5 degrees, you want to write it as fraction, right? 1.7 degrees. Once it's less than 90, positive angles less than 90, they are acute. All right, so let me just check the chat to see if I'm getting any questions yet. Remember, those in the chat, ask your questions, and if you see me answers as well, and your comments, right? Anything you want, just participate, and so you can make the best of the class. All right, so if you want to jot down your notes, so you would say an acute angle is an angle that measures less than 90 degrees. So let us go now to the other type of angle, and we're doing them in order of size. So the acute angle is the smallest. So now we go to the next in line, which is the right angle. So the right angle measures exactly 90 degrees, nothing more, nothing less. Exactly 90 degrees. Now, a 90-degree angle is formed when we have a vertical line meeting a horizontal line. And we are, as usual, we are pretending that these lines are perfectly straight. You all know I have an issue with drawing straight lines. So we are pretending these lines is a straight vertical line, perfectly straight horizontal line. They meet each other at right angles. So another word for them is perpendicular lines, right? So perpendicular lines meet each other at right angles. So if you were to take the protractor and put it here where the T is, put it there, and measure that angle, you should get 90 degrees. Now, when we show a 90-degree angle, whether just as is with the lines or in a shape like a right angle triangle, we denote that right angle by a little box there, a little box in the corner, as opposed to how we normally put the other angles with a curve. So you would see the little box. Once you see the box, without being told, you can know that that is a 90-degree angle. Or if you are told that the lines are perpendicular, you know that it's a 90-degree angle. For the triangle, of course, you can't have more than one 90-degree angles because all angles must add up to 180 degrees, all angles in the triangle. So if we have 190 degree with the other two, none of the other two can be 90 because they must add up to 90, right? So we'll split the other 90 between these two. So these two must both be acute. And there's a special right angle triangle that has two equal acute angles where we split that remaining 90 into two. So two 45-degree angles and the 90 degrees. So that's a right isosceles triangle. Two equal angles of 45 degrees and a 90-degree angle. Bear in mind the right angle triangle doesn't have to be oriented this way. It can turn that way. It can turn this way. Anyway, it can be that way. It doesn't really matter. Once you have your perpendicular lines, they're going to have a 90-degree angle there, right? So that's the right angle. Next in line is the obtuse angle. Obtuse. So the obtuse angle is less than, sorry, I was going to say less than 90. The obtuse angle is greater than 90 degrees, but less than 180 degrees. Okay. So since the 90-degree angle would look as a little thing like that, so the 180 would be straight across, right? Straight across. So the obtuse then would be anywhere from here to there. So from this, come all the way around, anywhere from there. So once the angle is bigger than the 90, so once this line passes here and start going towards that direction, so anything like this or that or the other direction, that, right? So these are obtuse. They pass the 90 degree and they're going towards the 180. So even if it's 90.1 degree, it's obtuse. Or if it's 179.99999 degrees, it's still obtuse. Once it more than the 90 and it less than the 180. So 100 degrees of angle, obtuse. 158 degrees, obtuse. 96 degrees, obtuse, and so on, right? 179 and 3/4 degrees, obtuse. All right, so we've talked about the acute angle. We've talked about the right angle, and we've talked about the obtuse angle. So now let's talk about the straight angle. The straight angle is on a straight line. So it's the angle subtended right across a straight line in any direction. So whether the line wants to be horizontal, vertical, oblique, the entire angle from there to there is 180 degrees. So a straight angle is exactly 180 degrees. So you notice how the protractor look, the semicircle, and the protractor is 180 degrees. So it's a full protractor, call it that. If you put the protractor on the line, it will cover the entire angle, a straight angle. So if you are given a set of angles on a straight line, so that angle, so here we have 4 angles, and they are all together on that straight line. So you know that all of them must add up to 180 degrees. So if you know 3 of them, you can find the other one. Just add the 3 of them that you know, subtract it from 180, and you'll find the other one. And we're going to do that in our next class, finding missing angles. So that's why we're making sure to cover the basics to know. First, we did the types of triangles. Now we're doing types of angles. So we're going to do another types of angles class where we look at vertically opposite angles, alternate angles, and so on. Once we have covered our knowledge of angles, then we can look at finding the missing angles. All right, so we have 2 more to go. After the straight angle, we have the reflex angle. So the reflex angle, it's greater than 180 degrees, but less than 360 degrees. So remember now, so the 90 degree was that, right? And the obtuse carried up to 180. So now if it passed the 180, so anywhere past here, going up to the full 360. So anywhere past there, go round. So in other words, if the angle looks like this, that big angle there, that's obtuse. Or turn in the other direction, the obtuse angle is a big angle. So it's more than 180 degrees, but less than 360 degrees. So you can think of what? 226 degrees, 338 degrees. All of these are obtuse. 196 degrees. More than 180, less than 360. And the final angle that we're going to look at is the full rotation angle, which we also call angles in a circle. So the full rotation angle, or also called angles about a point, right? So angles in a circle, angles about a point. So basically we're saying if we have this point here and the angle makes a full rotation about that point, that's a full 360 degree angle, right? So angles in a circle add up to 360 degrees. So if we have a circle and we were to cut it up into smaller angles, it doesn't matter how many angles you cut it into, they all should add up to 360 degrees. So if you know, let's say they give you 5 angles, if you know 4 of them, you can add up the 4 that you know and subtract it from the full 360 degrees. And you will get the missing angle. And we're going to be doing things like that when we're finding the missing angles in triangles, in circles, in different types of shapes. And we're going to throw in some algebra in it as well. So for example, if we have this circle here, and I said this angle is x, this angle is x, this is x, this is 4x, and this is 3x, all right? We could put it like that, and I would want you to find all those 5 missing angles. So write a comment and tell me how would you go about working out each of those angles. So based on what we've said about the full rotation angle, how would you approach a question like that to find out each of those angles? So let me go to the chat and see what you're saying. How would you approach that? If I wanted to find out each of those angles in the circle, any ideas? Come on, scholars, think. Remember, we said all angles in a circle add up to what? All angles in a circle add up to 360 degrees. That's a full rotation. 360 degrees. So look at those angles there. I've named the angles. I haven't given you any degrees, but I've named them for you. One is x. Well, 3 of them are x. So those 3 angles are the same. One is 3x and one is 4x. So what we would do, we would form an algebraic equation. And we're just coming out of algebra class, learning how to solve algebraic equations. So we know that all of these angles must add up to 360 degrees. Therefore, 3x plus 4x plus x plus x plus x, that's all the 5 angles. They must add up to 360 degrees. So 3x plus 4x is 7x, plus x is 8x, plus x is 9x, plus x is 10x. So 10x is 360 degrees. Therefore, x would be, 360. X would be 360 divided by 10. So wherever you see x, that is 36 degrees. So now we can just fill in the missing one. So we know this is 36 because it's just x. That's 36 degrees. This is also 36 degrees. And this is also 36 because each of them is x. This one is 3x. So this is 3 times the 36. So 3 6s 18, 3 3s 9, and 1 10. So this one is 108 degrees. And this is 4x. So 4 times 36. 4 6s 24. 4 3s 12, and 2 14. So this is 144 degrees. Right, so this is the kind of thing we're going to be doing. Finding missing angles based on the information that we're given. So for now, I want you to, when you get the time, all right, so when you get the time, John, I'm just seeing your answer. Okay, so John said, Miss, we could add all the x's together and get 10x. So 36x equals 30. So x equals 36. Okay. So I want you to revise these basic angles. You have to have a strong knowledge of angles when you're doing trig or geometry. All right. So we have the acute angle, the right angle, the straight angle, the obtuse angle, the reflex angle, and the full rotation angle. So next class, we're going to look at other classification. These are the basic types. We're going to look at other classifications, right? Like the vertically opposite angle, alternate angles, which some people call Z angles, and so on. We look at those types of angles. All right, so that's it for trig class for today. Do your revision and do your practice. Always remember, practice. When we're doing math, that's one of the fundamental principles. Revise and practice.